Have you ever noticed this? Everything works perfectly on your local cluster, but the moment you move to production, nothing behaves the same. Networking breaks, storage behaves differently, and security blocks everything. And suddenly, you start thinking, maybe I don't understand Kubernetes properly. But here is the truth. Kubernetes didn't change. Your environment did. Hi, I'm Shivam. This is the fourth video of the series Data and Reality Check. Today, I will show you why Kubernetes feels easy locally but hard in production. And I will demonstrate it on my Kind cluster. So let's head on to the demo section. So as we can see, this is my cluster. I have one control plane node and two worker nodes. So let's start with networking. Let me go ahead and I will create a test pod using BusyBox image. I have already written the configuration for the pod. Let me copy it and we will go over it one by one. As we can see, the kind is pod. The name of the pod is nettest. It is using a BusyBox 1.36 image. So let me go ahead and apply this pod. So it says our pod has been created. Let's check that. So it says our pod is up and running. So inside Kubernetes, pods can talk to each other freely. No firewall, no restrictions. And we can see that my pod got scheduled on worker node 2. So let me exec into this pod. Let me try to ping google.com and we are getting the reply. So in production, outbound traffic might be blocked or network policies might exist or even a private subnet exist. But local cluster gives you unrealistic freedom. So let me exit out from this container. We'll clear the screen and we will look into service exposure illusion. So again, I'm gonna create a file called app.yaml and I'm gonna write a pod configuration and a service, in fact, a NodePort service for our app. So I have already written the configuration. Let me copy it and we will go over it. So as we can see, the kind is deployment. The name of the deployment is web. It has one replica. This time I am using an Nginx image and the container itself is running on port 80. Now the second component is service. The name of the service is web and it's a node port type of service. So there are total three kind of service in Kubernetes. One is the cluster IP service, which is the default service. The second type is node port and the third type is load balancer. So the service itself is running on port 80. The target port specifies to the container port. So these two, target port and container port, should match with each other. And the node port is 30,001. So let me go ahead and apply this file. So it says our service has been created. Now let's try to access our service from browser. And we can see the welcome page for Nginx. So locally, NodePort just works fine. However, in cloud, you need a load balancer, firewall rules to access your application from the internet, and an ingress setup for the same. But in case of local cluster, all the above mentioned steps and complexity are hidden. Now let's look at the storage reality. Similarly, I'm gonna create a pvc.yaml file. I have already written the configuration for it. Let me copy that. So as we can see, the kind is persistent volume claim. The name of the PVC is test PVC. Access mode is read write once and it is requesting 100 MI of storage. Let's apply this. It says PVC created. And we can see our PVC is in pending state because we have not created any pod which can consume this PVC. If you have watched my previous video where I have explained persistent volume and persistent volume claim, you should have an understanding that how PVC, PV and pod works together. So coming back to this video, our PVC got created, no waiting. However, in cloud, provisioning takes time. Storage class matters. Even there are multiple availability zones. Attach and detach delays happen. Many times in production, you will have to ask your storage team to create storage class for a cluster so that you can request certain amount of storage using PVC. However, local storage is just fake simplicity. Now let me clear the screen. Now we will look into one of the security illusions what we face in production environment. So let me create another file called secpod.yaml. I have already written the configuration. Let me copy it. So as we can see, the kind is pod. The name of the pod is root pod. It is running an Nginx image. And this time I'm using a security context run as user equal to 0. So what does these two line means? So this means that run this container with user ID equal to 0. And in Linux, user ID equal to 0 is the root user. However, one important thing to note here is in production environment, you will never be allowed to run any command as root user. So let me apply this pod and we'll see what happens. So it says our pod has been created. Let's check it and it says our pod is up and running. So it works locally, but in production, as I mentioned before, this would be blocked. It could be pod security policies, admission controls, runtime policy, or even compliance rules. Local cluster has minimum to no security. However, production has many security rules. So now you see, local Kubernetes cluster gives you open networking, instant storage, and minimal to no security. However, in case of production environment, networks are restricted, real storage behaves differently, and there are strict security protocols. Kubernetes didn't become harder, but reality becomes stricter. This is why whatever we saw in this demo works perfectly on local cluster. But this doesn't mean or guarantee that whatever we did in our local cluster will work in production environment. And understanding this gap is what makes you production ready. I hope you will be able to learn something meaningful out of this video. I will see you in the next one. Till then, keep learning.